One of the important objectives when you work with the computer is to store and manage huge amount of data, and this can be done by using the concept of databases. Hello friends, welcome to Dev's Coding Hub, and our today's topic is Introduction to Databases. Let us start with data and information. What is data? Data is nothing but raw facts and figures. And whereas information is the processed form of data. So these are the simplest definition of data and information. Let us take one example of data. Suppose name Rocky and age is 8. So this can be termed as raw fact and figure because Rocky could be a name of a person or it could be name of a dog also, and the age could be 8 for either the dog or the boy. So it is not clear, it is not having any meaning. So this is data. Whereas if I say Rocky is my brother and he is 8 years old, it means something. Now I can say Rocky is a human being, not a dog. Let us see something more on data. Data is actually divided into two categories: qualitative. Qualitative data is descriptive information. It is descriptive in nature. It describes something. Let us take the example. Say, if I want you to grade this session, somebody may grade it excellent, somebody may grade it good, somebody may grade it bad also. So, quality depends upon person. So, rating of a movie is also a qualitative data. Next one is quantitative data. Now, quantitative data is numerical information. They can be represented using numbers. Again, quantitative data is divided into two categories. First one is discrete and the second one is continuous. Let us take one example of discrete data. Suppose colors in RGB color code. It is always 3. It is a number that can represent how many colors are there in RGB color. Next one is continuous. Suppose IQ score of a highly intelligent person, it ranges from 145 to 159. So any value from 145 to 159 can be considered as a continuous data. Now let us see something more on information. Information could be factual. Factual information solely deals with facts. So it is derived from facts. Suppose some people keep long beard. So it is a factual information. Next one is analytical information. It is the interpretation of factual information. When we analyze factual information, we may derive some more information, which is called analytical information. Suppose the forecast of sales for the next year based on the analysis of data, sales data from previous 3 years. Third one is subjective information. It is information from only one point of view. It is actually related to a particular person. Suppose let us take one example. The patient tells that he have had headaches on and off for the past 2 weeks. This information may be biased. The patient may be lying. So it is subject to observation and analysis and check. Next type of information is objective information. Objective information is understood from multiple viewpoints and presents all sides of an argument. These are basically given in books. Okay, objective information is stored in books. Let us take one example. The Tyrannosaurus rex was a prehistoric carnivorous dinosaur. So, it is objective information. And when I talk about data and information, there must be some differences between the two. Let us see the differences between data and information. Data is nothing but raw facts and figures, whereas information is processed form of data. Next one is data is not dependent on information because information is derived from data. Data is not derived from information. It is derived from observation, but information is totally dependent on data. Next, data is unorganized. It is not meaningful and it is not organized properly, but information is organized. Data can't directly help in decision making because it has no complete meaning, whereas information has complete meaning, thus it can be used for decision making. Let us move on to the next topic, database. A database is nothing but a collection of interrelated information that are organized in such a way that it can easily be accessed, managed, and updated. An example of a database may be a dictionary where words are arranged alphabetically. A telephone directory can also be an example of a database where subscriber names are enlisted in alphabetical order along with the telephone numbers they have. Our next topic is DBMS. Now let us see what is DBMS. DBMS stands for Database Management System, and it is a collection of programs that enable the user to create and maintain computer-based databases. Now two examples of DBMS softwares are DBase2 and Clipper. Now DBMS software is used to store information in a database as a single file. They store data as database files. As for example, DBase2 database is saved with an extension of .dbf. Now let us see what is RDBMS. RDBMS stands for Relational Database Management System. It is also a special software and it is the advanced version of DBMS software. Now examples of RDBMS are MySQL, SQL Server, Oracle, DB2, Sybase, or as such. In RDBMS, instead of storing data in a single database file, data is stored in multiple small and manageable tables. So data in RDBMS are stored in tables, and these tables could be linked with each other so that we can fetch data from multiple tables. Now let us see the difference between DBMS and RDBMS. DBMS generally stores data as a file. Okay, as I have given the example in DBase2, it saves the data with a .dbf file. So every file is a database. But RDBMS store data in table objects. So RDBMS stores it and manipulates data as a collection of objects. Table is the primary object where data is stored. Now relationship between database cannot be created in DBMS, which can be done in RDBMS. Data redundancy can't be controlled in DBMS. That means there will be repetition of data. But in RDBMS, data redundancy can be controlled to a great extent. DBMS only supports single user operation, but in case of RDBMS, we can have multiple user support. Next difference is DBMS can handle low volume of data, low or moderate volume of data. But as compared to DBMS, RDBMS can handle a huge volume of data. DBMS gives low data security, whereas RDBMS gives us high data security. So these are the basic differences between the DBMS and RDBMS software. Now let us take a look at the primary data object, which is called the table. In RDBMS, a table is the primary object that stores data. In RDBMS, a table is a grid of rows and columns that are used to store data. Now let us see the elements of a table. So this is one table structure. So let us point out the different elements in this table. This first one, the top row, it is not actually a row. So this is the name of the table, which is student. So this table will store information about students. Now for storing data, a table is actually divided into some columns. These are called field names also. So roll number is a field name is another field name, and marks is the third field name. So we have three fields here. Field 1 is roll number, field 2 is name, and field 3 is marks. So all these three fields denote that we will store only these three types of information about the student in the student table. Now, if I see the data stored in intersection of column and row or column, okay, this will give us a rectangular box where a single data is stored. These are actually called data items. So 1 is data item, Vikram is data item, and 85 is also data item. Now after data item, we will go for the individual rows that represents information of one student each. So every row is representing data of one student. So let us see the first row. Here the roll number is 1, name is Alokesh, and marks is 84. So this is the information of a student. This is called record. So these three are the records or information of 3 individual students. So let us see more details of the table. Let us find what is the name of the table. The name of the table is student here. Number of fields 3, as because roll number, name and marks are the 3 fields. Number of records, record 1, record 2, record 3, 3 records. And total data items will be number of rows into number of columns. So we have 3 rows and 3 columns. So 3 into 3, it will be 9. So remember, the column heading or the field names are not considered as data, as because they are the parameters according to which data will be stored for a student. They are not actually the data. They are parameters for data. They are the headings under which data will be stored. So let us see some important database terms. First one is a table. A table is a rectangular grid that stores data in a database. And this table is also known as relation or entity. The next one is a column. A column is a vertical line in a table and its heading is called column name or field name or attribute. So a table is made up of some attributes or field names. Then when I store one set of information by filling up all the columns or attributes in the table and I complete one row, it becomes a row and it is also called record or tuple. The number of fields or attributes that are available in a table are called its degree. So in the previous example, whatever table we have seen, the degree of the table is 3. Why? Because the table has 3 fields or attributes. Now the number of records available in a table is called its cardinality. Cardinality keeps on changing as we enter more records. Now let us find out whether we can identify the cardinality degree or not. So this is the table. If I ask a question, what is the table name? The table name should be student. What is the second attribute? The second attribute is roll number is the first. Second attribute is name. And then what is the cardinality of this table? This table has 1, 2, 3. 3 rows. So the cardinality of the table is 3. And what is the degree of this table? This table has 1, 2, 3 columns or attributes. So the degree of the table will be 3. Now how many data items are there in this table? It will be 3 into 3, 9 data items. Hope you have understood and you have found the correct answer. Now we'll go for RDBMS software called MS Access or Microsoft Access. So what is Microsoft Access? Microsoft Access is an RDBMS software developed by Microsoft. It is distributed as a part of the Microsoft Office package. If we install Microsoft Office package and some of the version of Microsoft Office packages, we have MS Access. Now, MS Access is a weak RDBMS as because it doesn't implement some of the RDBMS features like database triggers, stored procedures, transaction logging completely. So it is a weak RDBMS software. However, it can create a relationship between the tables in a particular database using database keys. So the basic thing which is creating relationship between small tables to fetch data from both the tables can be done in MS Access. Thus, it can be termed as a RDBMS. Though weak, it is a RDBMS software. Now let us go for the concept of database keys. What are database keys? A database key is one or more fields that is used to create relationship between two tables. If I want to link two tables and fetch data from two tables or manipulate data that are there in two tables, I have to create a relationship. And this can be done by using database keys. Now let us see this product table where you have the product ID, then the P name, which is product name, price of the product, and quantity on hand. That means stock of that particular product. How many quantities of that product is there with us? It is called quantity on hand. Now product ID could not be duplicate. Like your roll number is not duplicate in your class. Similarly, a product must have a unique ID. So this is actually a key field. PID is a key field, and this kind of key field is called primary key. And let us see, if these products are sold, these products could be sold multiple times. One product could be sold multiple times. So there must be a sales table when I sell. Okay, in sales table, we must have an invoice number, which is denoted here by INO. Invoice number means the unique number given to each invoice. So S1, S2, S3 are the invoice numbers we have given. So no two invoice numbers should be same. So this can be termed as a key field, as because it is storing unique values. Similarly, when I sell product, I need not have to write all the details of the product, because I have the product ID here in the sales table. So by linking this product ID from this product table to sales table, I can easily fetch the name of the product and the price of the product, and also I can see the quantity on hand for that product. So there is no need for storing the product name, price in the sales table. Okay, it can be fetched when you make a cash memo or this invoice in printed form. I can fetch the P name and price from this product table, as because we can create a relationship between these two tables because they have the same field. So here you can see I can link this product ID of product to this product ID of sales. Now this kind of relationship will be termed as one-to-many relationship, and we have denoted this by 1 and M, because in product table the product ID will be unique. So there will be only one product ID for one product, but that same product can be sold multiple times. So this P1 may appear in the sales tables twice, because Alokes also has purchased Lux, and similarly Devashish has also purchased Lux, because their product ID is P1, and for P1 the product name is Lux. So a product could be sold many times, so it is a one-to-many relationship. We'll go further into details how relationship can be created when you do it practically. Now let us go further into the concept of keys. The first type of key we can create is primary key. A primary key is nothing but a unique identifier for each record. Next one is foreign key. Foreign key is a link of primary key in another table. In our previous example, what we have shown, that in that sales table, that product ID is a foreign key, as because it is a link of that product from the product table. Number 3 is candidate keys. All unique value fields from which primary key can be selected are termed as candidate keys. Now, a table may have multiple unique value fields. Suppose I have serial number as well as roll number. Both can be used to identify records uniquely. So, until and unless I set one as primary key, these two will remain as candidate keys. That means candidate for the primary key. Now, alternate keys. Alternate keys are all those fields that are unique but not chosen as primary key. So after selection of primary key, all unique value fields other than primary key becomes the alternate key. Next one is super key. Super key is a combination of fields that at least contains the primary key. So primary key alone is the minimalist super key. Next one is composite key. Suppose if there is no unique value field in a table, we will not be able to identify records uniquely. As because we cannot use one field to identify a particular record uniquely, we may combine two or more fields or attributes to make the primary key. When a primary key is made up of two or more attributes or fields, it is called composite key. So let us see all these concepts in details. Let us discuss candidate keys first. Take this table as a reference, which is students underscore 8B. In this table, we have serial number, roll number, and student ID as three unique value fields, because student ID will be unique for every student, roll number will be also unique in a particular class and section, and serial number is always unique. So these are the three unique value fields. All these three will be termed as candidate for being the primary key. So they are called candidate keys. So all unique value fields that are capable of being the primary key are called candidate keys. Now remember, the concept of candidate keys prevail until we create the table and set the primary key. Once primary key is set, there is no concept of candidate keys. Let us go for the next key, which is primary key. Suppose from these three candidates, we don't select serial number or student ID as primary key, but we select roll number as primary key. So you omit these two and select roll number as primary key, and it can be done when we are actually creating the structure of this table. When we are creating the table, then only we can select it as primary key. Remember, there should be only one primary key in a table. Now let us discuss alternate keys. I have already discussed that out of these three candidate keys, we have selected the roll number as primary key. When primary key is selected, the rest of the candidate keys that are not selected as primary key becomes the alternate keys. So candidate keys that are not selected as primary key are called alternate keys. So in this case, serial number and student ID will become alternate key. The candidate keys that are not selected as primary key will automatically become alternate key. Then the super key. I have already told you that the super key is nothing but a combination of fields where you have at least the primary key. The primary key is considered as the minimalist super key. Suppose in this table we have selected roll number as primary key, and thus it can be the minimalist super key. Now if I combine roll number and student ID, then also it can be termed as super key. Why? Because it contains the primary key. Similarly, roll number, student ID and name could be combined to form the super key again. So super key is nothing but a combination of fields that contains the primary key, and the primary key is called the minimalist super key. Now foreign key. Let us jump back to our old example of the product and sales table. In this product table, PID is the primary key here. Now we can identify the primary key. It is written in white color. So it is going to identify each record uniquely, because if I say P1 product, this will be the record only, nothing else. If I say product P2, the second row will be picked up. If I say product 3, it will be the third row only. So there is a way we can identify each record uniquely, which is called the primary key. So PID here in the product table is primary key, and it is going to be unique for each and every product, as you can see it in the data. Now when these products are sold, it must be entered into sales table. But if I want to store the information of products in sales table, I have to store PID, P name, price, okay, all this. But instead of that, what we can do, we can keep this product ID in sales table also. Now in sales table, it is acting as a reference of product, so it is called the foreign key. So what is foreign key? Foreign key is nothing but a reference of primary key in another table. That means if primary key field of a table is kept in another table, it is kept for the linking purpose, okay, and this time this will not be called primary key, this will be called foreign key. So foreign key is nothing but a link of primary key in another table. So if I have a link, I need not have to store the product name and price here in the sales table. And sales table may have its own primary key, like we have invoice number denoted by INO in this particular sales table. So if I have my primary key, still I may have a foreign key also, okay. So this product table is basically the primary table, because if we have product, then only we can make sales. That's why in the product table, primary key is PID. It will uniquely identify each product, and in the sales table, it will be acting as a reference, so that we can pick other values, other fields information from the product table, and we can make less redundant data stored in sales table. Because if a product is sold 5 times, the name of the product will be repeated 5 times unnecessarily. We will have minimal repetition of data in case of RDBMS. So this product ID which is there in product is the primary key, and the PID which is there in sales table is called the foreign key. And we can link this to fetch data from both the tables. And this is a one-to-many relationship. Why it is one-to-many? Because one product could be sold many times. Because see, P1 which is lakhs is sold twice. Once it is purchased by the customer Alokesh, and the second time it was purchased by Debashish. So this is the concept of foreign key. So let us move to the next concept, which is called the composite key. Composite key is nothing but a primary key made up of two or more columns. Now let us consider this table student, where instead of storing data of a particular class and section, we are storing the entire student's information in a single table. And here we have roll number, class, section, name and age as the 5 fields. Now see here, this roll number is having duplicate values, so it cannot be termed as primary key, or it cannot be set as primary key. Similarly, if I combine roll number and class, then what we can see, the combinations are unique or not. 1 5 it is unique, 1 4 it is unique, 2 5 it is unique, 1 6 and 1 6, these two are not unique. As a combination also they are duplicate. So roll number and class together cannot be termed as primary key or set as primary key. Now let us consider roll number, class and section, these 3 fields. Now see, 1, 6 and B, that means roll number 1, class 6 and section B is separate from roll number 1, class 6 and section A. So if I combine roll number, class and section, I'll be able to identify a particular student's record uniquely. So in case of such problem where one field is not unique and cannot be assigned as primary key, to set primary key we can combine 2 or more fields. Now this will be termed as the composite key. So composite key is nothing but a primary key. Why it is called composite? Because we have 2 or more fields in it. So that's all about composite keys. Now let us go for some sample questions. So these are the 7 questions. I hope you'll try this and write the answers in comment section. So that's all for today. Before we leave, see this beautiful quotes from Arthur Ashe.